Hi everyone, welcome to Online Watch. Chemical bonding is nothing but for getting stability, the elements are losing electrons or gaining of electrons takes place. Nothing but the electrons are sharing or transfer of electrons taking place. In this process, one bond is formed. That resultant bond is known as chemical bond. Listen once again. The electrons are losing takes place or gaining takes place. In this process, that bond is formed. That resultant bond we call it as a chemical bond. In this chapter, the first theory is Lewis dot structure. The first theory is Lewis dot structure. Okay, this theory was explained by Lewis. He says in this theory, the elements in their electronic configuration, what are the outermost shell contains the electrons. That electrons are we have to represent as like dots. Dots are a cross symbol. Lewis dot structure are a cross symbol. Whatever it may be, what are the symbol we can use. I will take the example sodium. Sodium element, the atomic number of element is 11. The electronic configuration of this element is 1s2, 2s2, 2p6, 3s1. In this electronic configuration of this element, the outermost shell is 3s1. This is the outermost shell of this element. So in this outermost shell, the element contains only one electron. These are the electrons. Only one electrons there in their outermost shell. So the outermost shell electrons for this sodium is 1. We can call it these electrons are outermost electrons are valence electrons. Outermost electrons are valence electrons. What are the valence electrons? How many valence electrons are contains? That electrons we can represent with dots. So this element sodium contain only one electron in their valence shell or outermost shell, whatever it may be. So only one electron is there. So we have to represent that one dot on the element like this, Na dot. This is the Lewis dot representation or cross symbol, Na cross. Whatever it may be, we can use both. If you take the another example, if you take chlorine atomic number is 17. The electronic configuration of this element is 1s2, 2s2, 2p6, 3s2, 3p5, 17. You already know how to write this electron configuration. So 2, 2, 4, 6, 10, 12, 5, 70. Last two shells in this element we call it as outermost shell or valence shell. In this shell, how many electrons are there? Here 2. In 3s2, 2 electrons are there. In 3p5, 5 electrons is there. Total 7 electrons. So 7 valence electrons are there. 7 valence electrons are there for this chlorine element. So 7 dots we have to present on this element. So 7 electrons, 1, 2, 3, 4, 5, 6, 7. This type the Lewis represents, dot represented we can present on the element. On the element where you have to present the element, we can present anywhere on the element. For example, sodium contain only one electron. So I represent this dot here. You can write here, whatever it may be the place. But on the element you have to represent. Okay. That is the Lewis dot structure. This is for elements. We can write this Lewis dot structures for molecules also. For example, if I take molecule carbon dioxide and take carbon dioxide CO2. In this carbon dioxide, the central atom is carbon and these two are attached elements, oxygens. The central atom carbon. The valence electrons are carbon is 4. Why? Because carbon atomic number is 6 and the valence electrons are 4. So 4 dots we have to present on the carbon elements. 1, 2, 3, 4. Here 2 oxygens is there. Surrounding on the central atom 2 oxygens is there. One oxygen I am writing here and another one I am writing here. Each oxygen containing in their valency shell 6 electrons. 6 electrons are there. Oxygen atomic number is 8. If you write the electronic configuration like this for oxygen element, the outermost shell containing 6 electrons, valence electrons. That 6 valence electrons we have to present like this: 1, 2, 3, 4, 5, 6. As like this element also. So this oxygen, this is same. So this oxygen also containing 6 valence electrons. We have to represent like this: 1, 2, 3, 4, 5, 6. This is the molecule Lewis representation. This is the element Lewis representation. For elements like this, we have to represent Lewis dots. For molecules, Lewis dots we have to represent like this. This is the Lewis dots structure representation.